Section 11.5 is regarding counting and permutations. I'm going to split this section up into a part 1 and part 2. So make sure you watch part 2 before you start section 11.5 in your skills practice. All right. Suppose 5 friends go to the movies. Person A, person B, person C, person D, and person E. All right. I want to know what are the different possible order or combinations that they can sit in their seats. So, will person A sit next to person B? Will person B sit next to person D? And so on. So I'm just going to list a few possible examples that they can sit. Right now we can have A. We can have A sit next to B, C, D, and E. That's one possible order. Another possible order is A can sit next to B, C, and then E and D can switch. So, once again, that's a completely acceptable order. E and D just switch their spots. We can have A, B, D, C, and E. We can have D go first, then A, then B, then C, then E. And we can have C, D, A, B, and E. And obviously, we can go on and on and on and on. I want to know what are the total possible combinations that I can have. What's the total number orders that these 5 people can be arranged in? Well, instead of listing all the possible situations, let's look at each event individually. All right, here are the 5 seats at the movie theater. So what we want to do is we want to see how many people can sit, or how many choices do I have for the first seat? That's a better question. How many choices do I have for the first seat? Well, we know that person A, B, C, D, or E could sit in the first seat. So that leaves us with 5 choices for the first seat. All right, let's suppose person A sits in that seat. So let's just suppose person A sits there. How many choices would that leave me for the second seat? Well, that will leave me with B, C, D, and E. So how many choices is that? That's 4 choices. So let's suppose, choose somebody random. Let's suppose person E sat there. Okay? So now we at the third seat. And the question once again goes, how many choices do I have for the third seat? Well, that would leave B, C, and D. So that would be 3 choices for that seat. And let's suppose B sat there. Now we're at the 4th seat. How many choices would I have to sit there? And you guys get the idea. We would have 2. And let's suppose that's C, and which only leaves us with 1 choice now for the 5th seat, and that would be D. So we have 5 choices initially for first seat, 4 choices for the second seat, 3 choices for the third seat, 2 choices for the 4th seat, and 1 choice for the 5th seat. So how does that help us determine how many possible choices I have to fill these first 5 seats? Well, what we're going to do is we are going to multiply each of these numbers together. 5 times 4 times 3 times 2 times 1. And what you're going to get is 120 total possible combinations. All right, we see that there are 120 total possible combinations for the first 5 seats. But what about if I just ask you what are the total possible combinations for the first two seats? How would this look? All right, so what we have is we have the first seat and the second seat, but we still have those same 5 friends. So what we're going to do is the same question needs to be asked. How many total possible combinations can I have for the first seat? Well, we know that there are 5 people, so we know that person A, B, C, or D can sit in that spot. So once again, we write 5 possible combinations for the first seat. For the second seat, the same issue took place in the last problem as it does in this one. If we have one person sitting in the first seat, then that leaves only 4 friends for the second seat. So that leaves a possible combination of 4 for the second seat. So our total possible combinations for the first 2 seats will be 5 times 4, which is 20 total possible combinations. So what are we doing? We're simply multiplying the events and their possibilities times each other. So in the first event, we had 5 possibilities, and in the second event, we had 4 possibilities. So you multiply the 2 events together, and that tells you the total number of combinations for that particular event. All right, suppose that I was interested in the first 3 seats being filled. Once again, starts out the same way with the first 2 seats. There's 5 possibilities for the first seat. Once we get one person sitting in there, that only leaves 4 possibilities for the second seat. Once we sit one more person down in that seat, that leaves only 3 possibilities for the third seat. So once again, we get to multiply these together. So 5 times 4 times 3, and that answer is 60 possible combinations. What we just learned is called the fundamental counting principle. It says if you have m choices for the first event and n choices for the second event, then the number of choices for both events is m times n. Obviously, we can keep going for more events like we did when we took into consideration the first 3 seats in a movie theater. That would have been m times n times whatever other variable you wanted to use. Now, let's look at the problem. The movie theater has 6 different beverages and 9 different snacks. How many possible combinations can I have using the different beverages and the different snacks? Well, let's take a look and think about what would I have for the first event? Well, the first event is different beverages. How many possible choices can I have? You got it, 6. Well, let's take into consideration the second event. How many different snacks can I have? 9. So how many possible combinations can I have? 6 times 9, which is 54. So that's 54 total possible combinations that I can have if I had 6 different beverages and 9 different snacks.